Very good morning, students. Welcome to the another session of irrigation and hydraulic structure subject. Now we are going to discuss about the third unit, which is having two different topics. One is earth dams and the second topic is spillways. So in the first half we are going to discuss about what is earth dam and what are the different types of earth dams are available, and also how the classification of earth dams is made based on what criteria it is made, and also we will discuss about causes of failure of earth dams. What are the different reasons or causes for the failure of dam? Along with that, we will learn about criteria for safe design. What is the criteria to be followed for the safe design against seepage through the dam or through the foundation of the earth dams? And also, what are the measures to be taken for the control of seepage through the earth dam? So these are the topics which we are going to discuss in the earth dams concept. Okay. Now coming to the spillway, we are going to learn about what are the different types of spillways, what are the design principles to be adopted for the Ugis spillway, and also what are the spillway gates, what are energy dissipation and stilling basin significance of jump height curve, and also we will learn about tailwater rating curve and what are the USBR as well as Indian recommendations for types of stilling basins. So these are the topics which we are going to discuss in the third unit. Now let us get into the first topic, that is earth dams. So if you see the earth dam content, we know. What is the earth dam that we know? It is constructed by forming an embankments on the either sides of the material. So these earth dams are constructed very simply by using locally available materials. It may be locally available soils or locally available rocks. By using them with less skilled labor also we can construct earthen dams. Comparatively, the height is very less compared to gravity dams and the base width is more. Okay, so that is the reason the causes of failures and the number of loads acting on this earth dams will completely different from the gravity dams. Now coming to the classification or types of earth dams. Based on the purpose or method of construction, of earth dams, there are two classifications. One is the rolled filled dam, the second one is hydraulic filled dam. Coming to the rolled filled dam, in this manual methods of operations, manual mode of construction procedure is adopted, like the layers are formed, different successive layers are formed and they are compacted with rollers. Okay, so they are forming a different layers and they are compacted by the rollers. So this is the manual mode of operations are adopted in rolled fill dam. Coming to the hydraulic fill dam, here hydraulic machinery is used. Hydraulic machinery is used in the construction operations like the soil excavation, soil transportation as well as soil placed at the site, construction site is completely mechanized. Hydraulic methods are adopted in the hydraulic fill type of dams. So this is classification is based on the method of construction adopted, right? Rolled filled dam and hydraulic filled dam. So that is the basic difference between these two. Now moving on to the next slide, that is earth. What are the different types of rolled filled dams? See, depending on the type of embankment adopted, these rolled filled dams are classified into three types. One is homogeneous embankment type, the second one is zoned embankment type, and third one is diaphragm embankment type. So here coming to the homogeneous embankment type, here the material used in the construction is only a single material. So that is the reason we are calling it as homogeneous embankment type. Coming to the second one, zoned embankment type. See, here in the zoned embankment type there are two different materials, or we can call it as more than one material is used in the construction of this particular type of dam. Now coming to the diaphragm embankment type, a diaphragm is placed at the center of the dam, like a core. Okay, so this diaphragm is arranged at the center so that stability is attained to the gravity dam, this earthen dams. Okay, so these are the basic types of rolled filled dams based on the embankment type adopted. Okay, now coming to the next type, that is rolled filled embankment type. Here in the picture you can see, this picture you can see here, in this there are two different types are there. One is purely homogeneous and the second one is modified homogeneous. In purely homogeneous, what we are doing is we are constructing the entire this dam with respect to your single soil material. Okay, so this one is impervious foundation. The foundation is completely impervious, and whatever this embankments are formed, these are formed by using one type of material. Now coming to the second type, modified homogeneous. In this, here some kind of drainage, for drainage purpose they have provided some used one more material. So this is called as modified homogeneous dam. Okay, so for the drainage purpose they have used one more material. Okay, now coming to the zoned embankment type, already discussed. So this is zoned embankment type is more than one material. See here you can see this one is constructed with one material. So whatever this upper portion is there, this is constructed with one material and which is forming a one zone. Okay, now coming to the inner core, whatever this core is there, this is impervious core. Water cannot be passed through this, whereas the outer shell is a pervious one. Water is flowing through this pervious type of material. Okay, so we are forming two different zones. So that is the reason we are calling it as zoned embankment. Different materials are used. Two types of materials are used here. And now here you can see, like previously we have seen, here also some horizontal drainage facility is provided at the toe. Okay, so this is zoned embankment. Now coming to the diaphragm embankment. See here, this is the diaphragm embankment. See, this is the diaphragm which we are providing here, and this is a pervious foundation. Here we are providing, and below that we are providing impervious layers, and this diaphragm, and here also we can provide the impervious material. Okay, so this impervious material is provided here. Okay, so this is the example of diaphragm type of dam. Okay, now coming to the causes of failure of earth dam. What are the different causes of failure of earth dam? See here you can see on the basis of investigation reports. Based on the investigation reports, there are three main different types of failures are there. One is hydraulic failures, the second one is seepage failures, and the third one is structural failures. Now coming to the first one, hydraulic failures. See, there are four different types of hydraulic failures are there. One is overtopping, the second one is wave erosion, third one is toe erosion, and fourth one is gullying erosion. See, what is the meaning of overtopping? Overtopping is that whenever you see, whenever we know that the earth dams are not provided with spillways. So that is the reason the water cannot be transferred or cannot be flowed from the upstream side to downstream side, because there is no spillway provided, as we have seen in the gravity dams. Okay, so as no spillway is available, water should not overflow from the top of the dam, earth dam. Okay, so if that overflow is occurred, then what happens? It may lead to the whatever this downstream side is there, it is completely get eroded, which may lead to the failure of the earth dam. So generally, why this overtopping occurs? It is because of the underestimation of the maximum design flood. Means maximum flood levels are, if it is they are underestimated, then what happens? These kind of overtopping failures may occur. Okay, so if the design flood is considered properly, it is estimated properly, then this overtopping problem will not be there. Okay, now coming to the wave erosion. For example, if you see wave erosion is that whenever heavy waves are coming like this onto the surface, then because of these heavy waves, whatever this upper portion is there, upstream surface is there, which may get eroded. Okay, now coming to the toe erosion, if the water is flowing like this through the foundation, so here what happens, slowly whatever the soil is there, so this soil may get eroded at the toe, which may lead to the failure of the dam. Now gullying is that through the foundation of the dam, there water finds some pathways. So through the body of the dam, through the foundation, the water finds the way and causing the erosion. All the amount of soil which is present at that gully will be eroded completely, and it is completely occupied with water, which may be more dangerous than the remaining three. Okay, so the failure may be sudden also sometimes. So these are the 4 different types of failures which are considered as hydraulic failures. Okay, so they are completely related to water, how the water is flowing from upstream side to downstream side. So depending on this, these 4 categories of hydraulic failures are given here. Now let's see. See, here you can see, right, overtopping we have seen, and this is the example of wave erosion. See, if the waves are coming like this, so whenever the waves are hitting here, so this soil may be deposited here. So this amount of soil is removed from this because of the splashing of waves, and this is deposited like this. So instead of straight like this, it is eroded. Okay, so here also you can see like a slip type of, so like this, instead of this upstream surface, so it may go like this. So whatever this top portion of soil is there, which may be slipped and deposited at this place. So these are the possible chances of wave erosion. Okay. Now coming to the second type, that is causes of failure of earth dams. The second type is seepage failures. So what is the meaning of seepage failures? Whenever the water is flowing from upstream side to downstream side, whenever it seeps from different ways, through the foundation or through the body of the dam, water always try to seep. Okay, so it has some different effects, like you have seen, seepage water may generate erosive forces. Means whenever water tries to seep through the soil, foundation, as well as through the body of the earth dam, what happens? It will erode all the soil on its way. Okay, so if all the soil is eroded, then what happens? Then it is completely filled with water, which may lead to the sinking or the sliding of the material will occur. Okay, so gradually what happens? The sliding will increase and the thickness may get reduced. If the thickness of the earth dam is reduced, it may water pressure may increase and it may lead to the gradual failure. Okay, now and one more important effect is the soil pore pressure can lift portion of soil mass, causing sand balling. See, here you can see the picture of sand balling. Whenever there is a pressure difference between the two adjacent ways, two adjacent sides, so because of this potential difference, in the pore pressure, in the potential pore pressure difference, so this kind of sand boiling will occur. Here you can observe there are so many different patterns are there. So this is called as sand boiling. So whenever water boils, what happens? The droplet will come out and they will be spreading like this. So here also sand boiling will occur whenever there is a pressure difference, pore pressure difference is there. Okay, so here you can see this is the pore pressure difference. Sand boiling is occurring. Okay. Now internal erosion of soil and progressive backward soil erosion also will occur because of the seepage. So what is the internal erosion? See, here you can see. Let us assume if the water is seeping like this initially, then what happens? So here the backward erosion will occur like this. Okay, so gradually it increases towards like this. Then after that it will get joined like this with the upstream surface. Then what happens after some time? This portion of the dam, earth dam, may be completely get separated and there may be chances of dike failure. Okay, so completely bottom foundation is get eroded and it is formation of dike failure. Now here you can see because of the heavy water pressure, so all the material, dam material is completely washed away. So this is called as backward erosion. So such kind of cases are already seen in the other countries, like you can see, right? This kind of failures are experienced. So based on the experience only, this sand boiling as well as backward erosion are generated and they have included in the design. Okay. Now reduces internal friction. So if seepage increases, it reduces the internal friction of the material. Okay, so these are the causes of failure of the earth dams. Okay, so this is called as piping. Okay, the second effect is sloughing. So what is the meaning of sloughing? Sloughing is nothing but it is the collapse or sliding into a hole or depression. Means towards the bottom side, the sliding or collapse of the material is considered as sloughing. Okay, so this sloughing under full reservoir condition, the downstream toe, whatever the downstream toe is there, it may get eroded under sloughing. Okay, similarly sliding or falling of the surface will occur on a steepy face. It may be on the upstream side, it may be on the downstream side as we are providing steepy slopes. So this sliding or falling will occur. And after that what happens? The sliding will simultaneously increases to slumps. Slumps will form and these slumps are very unstable. At any time they may gradually slow down. So as the slumps are forming and they are sliding down, the thickness of the dam will reduce. If the dam reduces, what happens? It may lead to the failure. Okay, so the failure of Sinker Creek Dam. Here one case study is given. The failure of Sinker Creek Dam is because of the backward sloughing. Just now we have discussed in the figure. So this one, this is backward sloughing. So like this, the Sinker Creek Dam is failed. So considering that as a case study, this kind of failures are included in the design procedure. Okay. Now here you can see, right, sloughing. What is the meaning of sloughing? So whatever this, it has to be like this, but this portion is completely get eroded. Means sliding is occurring. So here you can see this amount of portion is completely sliding and they have occupied here. So slided, sliding is occurring here and they are forming at the bottom. They are accumulated at this place. So this is called as sloughing. Okay. So slowly, because of the slope, they will slide and after that they will form some slumps, and because of the heaviness of the slumps, they will come again here. Slowly the thickness of this member may be reduced. Okay. Now coming to the hydraulic failures. This is third type of failure, hydraulic failures. There are so many different reasons for this hydraulic failure, so many different characteristics and different types of elements are to be considered in the structural failures. Okay, let us see. upstream as well as downstream slope failures due to pore pressure. Means whenever there is a pore pressure due to the construction, immediately after the construction, the pore pressure is very high. So because of this pore pressure, the downstream as well as upstream slopes may get failed. That is the first hydraulic failure we can experience within 2 to 4 years. Okay. Next, the second point is upstream slope failure is due to sudden drawdown. So due to the sudden drawdown of water, then what happens means suddenly the complete dam can be emptied. So such kind of things are very rare. So if the complete dam water is completely emptied at a time without changing the reduced in the levels, water levels, then this upstream slope may fail. Next important point is foundation slide due to spontaneous liquefaction. Means whenever the water seeps through the foundation of the dam, so liquefaction will occur. So the foundation get damaged due to liquefaction, and it may lead to the damage or failure of the dam. And failure by spreading and failure due to earthquakes as well as slope protection failures, and also failure due to the damage caused by the burrowing of animals, and also damage caused by the water soluble materials. So these are the important points to be considered as the structural failures. Now coming to the first point, upstream as well as downstream slope failures. Here you can see here excess pore water pressure. So because of this excess pore water pressure due to rapid drawdown, because of the excess pore water pressure, and what happens, see the material is coming like this, water pressure is increased here. So here hydrostatic pore water pressure is for drawdown water level. Okay, so this is water and this is material. Okay, so like this the sliding will occur, means the entire this portion is slided because of the drawdown pressure, rapid drawdown. Okay, right. So here this is the drainage facility. So when the dam is built across impervious as well as compressible soil, then what happens? Obviously the drainage is extremely slow, means water cannot be flowing through the impervious and compressible type. Okay, then what happens if the extreme slow drainage is there, and what happens? Excess pore pressure will be developed. If the excess pore pressure is developed, then what happens? We can see soil balling or foundation like backward erosion will occur. Okay. Suppose if the permeability is less than 10 to the power of minus 6 centimeters per second, no drop down in pore pressure. There will not be any drop down in pore pressure. For example, if the permeability is more, there are two types of chances of slidings. One is slow and continuous for 2 weeks. This sliding will occur very constantly and slowly, and continuously it will occur for 2 weeks of time. And there is one more type of sliding is there, that is rapid and sudden. Means catastrophic failure may be expected here. Sudden failure without giving any warning. Sudden failure means the loss cannot be recovered, damage cannot be recovered here. Okay. Now here you can see the second type, upstream slope slide during sudden drawdown. So during sudden drawdown of water, means water is emptied. Then in this particular case, what happens? Whatever this upstream surface is there, this may get slided like this. Okay, so the sudden drop down in water levels may also damage the upstream surface like this. Here you can see this picture. Okay, so for upstream slope, the critical condition is that when the reservoir is suddenly emptied, which is most likely not expected, but if it is the worst condition, the critical condition for this is if it is suddenly emptied without allowing any appreciable change in the water levels as a sudden drawdown. So these type of upstream failures may be there. Sliding will occur or erosion will occur at the upstream phase.